And today we are looking at question 3. Good day, everybody. Right, we're still continuing on that technical maths exemplar. It is quite an interesting question paper, that is. So if you haven't subscribed, please just hit that subscribe button. And if you haven't watched the first 2 questions, you're more than welcome to do so. Right, they are available for you to watch. Now let's look at question 3 as quickly as we possibly can. Right, so we've got, they say determine without the use of a calculator the value of x in the following. Right, 3.3.1 should be quite straightforward. Okay, so we've got an equation there, right? X minus 5, x plus 3, which is equal to 0. They've already factorized this for us, and it is equal to 0. So that means that each of the factors must be equal to 0, right? So therefore, x is equal to 5, right? Please remember to change the sign, or x is equal to negative 3. Please don't try and drag this any further, right? It's already in its most simplified form. All we need to do is just get the solution, right? So the next one, we've got x squared minus 2, x squared minus 3 rather, over 2, which is equal to x. Now the best thing to do is to make these both fractions. There's an equal sign that's separating them. So what we can do is that we can always cross multiply. Okay, we can only do this when there's an equation. We don't need to go through LCD in this case, right? But, well, we can, but in this case we know that we will arrive at the very same solution, right? If we cross multiply, so that means x squared minus 3 times 1. That should give me x squared minus 3. And then we've got, which is equal to 2 multiplied by x. That should give me 2x. So that means x squared. If I take the 2x to the other side, I'm going to place it in standard quadratic form, right? Minus 2x minus 3, and this is equal to 0. Now, can we factorize this? Are the factors of 3 such that when I subtract them would give me 2? So I'll have x and x. So that's 3 times 1, right? And I know that the 3 would be negative, the 1 is positive, so, and that is equal to 0. So x is equal to 3, or x is negative 1. And essentially that is how the cookie would crumble. Okay, right, so that's how we would get to that solution. So fortunately we did not have a variable as a denominator, because we know that what would make this unsolvable is if the denominator is equal to 0. So that is not the case here. Right, so we've got 3.1.3, 2 raised to the exponent 2x minus 1, which is equal to 64. Now the best way for us to always solve these is to make sure that the base on the left and on the right hand side are the same. And if the bases are the same, then we can drop the exponents, right? In this case, that's going to be 2 raised to the exponent. So if we raise it to the exponent 5, it's 32. So this is raised to the exponent of 6. So you can go and check it out, right? If I raise 2, 6, that's definitely 64. So the bases are the same. Then it means that the exponents, are also the same, are equal. So that means 2x minus 1 is equal to 6. And so 2x is equal to, take the 1 to the other side. Okay, that's 6 plus 1. Remember, it changes sign. Okay, so we can divide both sides by 2. And so x will be 7 over 2. All right, and that is how the cookie crumbles. Let's go to the next question. So finally we've got, so that's negative 5. They said we must represent this graphically as well, right? That's minus 5. Okay, So 1 minus 3x is greater than negative 5, but it is less than or equal to 10. All right, so firstly, let's get rid of that of that 1. So that means if I take it to the other side, it becomes minus 1, but that's minus 1 over this side, okay? Right, so we're left with negative 3x greater than negative 6, right, less than or equal to 9. So if I divide by negative 3, now remember, whenever you divide by a negative, the inequality changes sign. So what I will do on the other sides as well. So negative 6 divided by negative 3 gives me 2, but the inequality changes sign, right? So that will be x, that's greater or equal to 9 divided by negative 3, in this case would be negative 3. Okay, that's negative 3. Right, now how are we going to represent this graphically? So x firstly must be greater than negative 3. So our critical values are negative 3 and 2. Okay, and so that means in this case, when I look at it, x must be between those values, must be greater or equal to negative 3, right? There we go. And in this case, it must be less than or equal to 2. Rather less than 2. So 2 is not included. So remember, if we are including it, okay, you show it with that dot that is filled, okay, but if you are excluding it, you've got that dot which is shallow on the inside, right, which is actually empty on the inside. So that is what it looks like. This is our number line, okay, that's between negative 3 and 2, and in that case greater than negative 3, less than 2. And essentially, ladies and gents, that is how the cookie crumbles. I hope that you will be there when we answer question number 4, which looks like the application of algebra. I hope that you will look at that next time. For now, I'll see you guys again. Sharp, sharp.